We don't remember what happens. What we remember becomes what happened. It might seem strange, but your brain doesn't store memories like video files ready for playback. Instead, every time you remember something, your brain actively rebuilds that memory piece by piece. It uses things from sensory fragments, emotions, and contextual details. So these fragments are encoded into special patterns of neurons called engrams, basically the neural fingerprints of your experiences. This reconstructive process mainly happens in a brain area known as the hippocampus. This is crucial for forming and recalling episodic memories, that are those tied to specific places, moments, or events. But the hippocampus doesn't work alone. The prefrontal cortex, responsible for complex thinking, planning, decision making, this helps organize these scattered fragments into a more coherent story every time you recall something. Here's the fascinating twists. Neuroscientists, psychologists, and so on have discovered that the same brain regions used for remembering past events also activate when we imagine or plan future scenarios. This process is called constructive episodic simulation. In other words, memory and imagination are rather deeply interconnected. The ability to flexibly recombine bits of past experiences allows us to creatively anticipate situations we've never even encountered before. So there's a trade-off though. So because our brains reconstruct memories rather than replaying perfect recordings, this flexible system of ours, it's prone to errors. So this is what psychologists call false memory. And research on what's called the misinformation effect shows how easily our memories can be reshaped or distorted simply by hearing new or misleading information after the fact. Sometimes we become convinced that these altered memories are completely accurate, even though they're not. So from an evolutionary perspective, memory may have evolved primarily as a forward-looking tool, with its core function being to enable us to predict future events or generate adaptive strategies so that we can respond flexibly to our ever-changing environments. So perfect accuracy, while seemingly ideal, might not have been favored directly by evolution, because the neural resources required for flawless recall might compromise adaptability. The brain's reconstructive method of recalling events, however, allows for flexible recombination of past experiences, crucial for imagining and preparing for novel situations. However, this beneficial flexibility comes with trade-offs, including susceptibility to errors and false memories. So these inaccuracies themselves aren't adaptive per se, rather they're tolerated because the benefits of flexibility for survival outweigh the occasional costs of imperfect recall. That was a bit of a long one, but if you stuck around, thanks. Be sure to like, share, subscribe, comment any questions or other things you'd like to hear me talk about. Bye now.